Hey folks, welcome back. In this lecture, we are going to start talking about repetition. This is the idea of doing something over and over again. And so we're going to start off and talk about in the real world. So it turns out in the real world, this happens a lot. For example, every day in life, you eat and drink. And so you do that multiple times a day, and you do it every day. You might have classes that happen on Mondays, Wednesdays, and Fridays, or classes that happen on Tuesdays and Thursdays. And that means that every Tuesday and every Thursday, you go to that class, or every Monday, every Wednesday, Friday, you go to that class. And you do this for the entire semester. You also breathe every 3 seconds, you take a breath. And so there are things that you do repetitively, some of which you don't even think about, like breathing. But you continue doing it over and over again. And usually, most of these things have an ending condition when you stop doing them. Computer algorithms, they have to be very precise. So if you're going to have a computer do something and you want it to do it 3 times, you have to tell it that you want it to do it 3 times. The computer will happily obey, you just have to know how to tell it that. So, for example, if we wanted the computer to print out the word hello 3 times on the screen, so far the only way that we know how to do that would be with something like this. So you've got a class main and you've got a public static void main, and then inside of there we have 3 separate print statements. And for each of those, it will print out hello, hello, hello. And this works, but I would ask the question, what happens if I need to do this 20 times or 50 times or 5,000 times? Well, then all of a sudden writing that code over and over again would get pretty tiresome very quickly. And so it seems like there should be a way where we can ask the computer to do it more than once. So what we kind of want is this, some kind of way that we can say, I need you to do this 3 times. And that's exactly what a loop is. It's a way to tell the computer, I want you to just do this some number of times. There's actually different kinds of loops, and we're going to see the different ones as we go throughout the next couple of lectures. But some of them are done this way, where you say, I just want to do this 3 times, and other ones are going to happen until something else is true. And so, like if we think about your graduation, at the time that you graduate, you're done with classes, and there's really no reason to continue taking classes. So you continue to take classes until you graduate, is the way that you would really think about that. Okay, so really when you think about your life, it's actually one big loop. Every day pretty much works the same as a previous day. You get up, you have some kind of breakfast maybe, you go to class, you eat some kind of lunch, you study, you eat dinner, you watch a movie, you go to sleep, and you get up the next day and you do it all again. So there's a chunk of stuff that happens in between the loop, and it is repeated over and over again each day. And so that's kind of how we want to think about a loop. You want to think about there's something that's controlling how often you want to do it, which in this case is going to be until you graduate. And then there's something separate that is the list of items that you want to do in each one of those iterations of the loop, meaning each day is an iteration of the loop in this example. Okay, and just as a side note here, the internals of the loop can be more complex. They don't have to just be a simple set of 3 instructions or 5 instructions. You absolutely could have some if statements in there. And so if we take a look at this, really it's get up, that makes sense, and then eat breakfast. But really that might be an if hungry, eat breakfast. And going to class probably is an if statement for most people. If it's raining, maybe not so much. And then you've got eat lunch and you have, do you need to do homework? If you do homework, otherwise maybe study. So this is an if and this is an else. So my point is that all of the other things that we've learned before, like variables and if statements and booleans and all of those things can be inside of a loop. And they're just done over and over and over again, just like anything else. So don't feel like this is completely separate from previous things that we've talked about. It's not. It's a continuation of that. All right. So then let's talk about how do you know when you want it to stop? Well, it turns out with loops, there's more than one way that you can do it. Sometimes you need something that just happens 47 times. And other times you might want something that happens until something else is true. And these are actually slightly different cases. So when we're talking about registering for classes and taking classes and doing that every day, the question is, when does that really end? Well, it ends when you graduate. So it's not that you're going to do it 17 times or 19 times or 22 times. It's that you're going to keep doing it until you graduate. And you don't really know how many times that's going to be up front because, well, classes, maybe you can't get into the one you wanted and that adds another semester, or maybe you get done faster, you take a summer one year and you're able to knock some stuff out and you're like, okay, well, I got it done sooner. So it's not based on a just sheer number of iterations. It's based on I need to keep going until I reach the objective. So one type of loop is related to an objective or something that needs to be accomplished, and you keep doing something until you reach that accomplishment. The other type of loop is I just need this to happen 4 times. And it just depends on if you know upfront how many times you're going to need to do it. Sometimes you do, and sometimes you don't. In today's lecture, we're going to focus on the circumstance where you're doing something until you run into a problem or until you run into a solution, one way or the other, something that stops it out there. So, as I say, sometimes you'll have fixed numbers, sometimes you will have keep going until you reach something. So, let's take a trip down memory lane and talk about if statements here, because it turns out that the particular type of loop that we're going to look at today, which is called a while loop, works very similarly to an if statement. And so here on the slide, we can see this is what an example of an if statement might look like. We have if graduated is not true, then keep passing classes. And really, this would only check something once. And this is the thing that I need you to understand. An if statement only evaluates things one time and then decides if we're going to do it or not. A while loop will keep evaluating it until we reach the goal. So the difference between an if statement and a while loop is an if statement checks one time. A while loop will check until we reach the goal, however many times that happens to be. But other than that, the format is actually going to be almost identical. So you'll notice that for an if statement, there's a couple of different parts here. We have the word if, of course, and then we always have this set of parentheses, which contains a Boolean. And when I say it contains a Boolean, it contains a Boolean expression. So it could be 7 greater than 3. It could be A equal to A as characters. It could be a string dot equals another string. It could be, in this case, it's literally a Boolean. Graduated is a Boolean, so it's either going to be true or false, and I'm checking if graduated is not equal to true. But whatever it is, this must be a Boolean. And then the third and last part of an if statement was this part, which is the curly braces and whatever the code is that you want to execute. It's the body of the if statement, if you will, or the code, or the thing that you're trying to accomplish. And so the same thing is going to happen with a while loop. You're going to be able to put as much stuff as you want into that block, and it will keep doing it over and over. But again, the most important things here are you have this Boolean expression. It has to be there. And the if statement only happens if the Boolean is true. The same thing is going to be true for a while statement. And then you have this block of code that is the stuff that you're trying to do once in the case of an if statement or multiple times in the case of a while statement. All right, so let's take a look at our first while statement. So here we have Boolean graduated equals false. And so that's just setting up something for us at the beginning. And then we have a while loop. And so you notice that very similar to the if statement, we just put the word while, and then we have a set of parentheses, and in those parentheses, we have something that evaluates to a Boolean. And then we have the actual parentheses that have the code that we want to execute over and over again. All right, so the way this works is Boolean graduated is false. So when we get to this first line of code, it checks to make sure that what's in here is true. Well, false not equal to true is true. I know that's a bit confusing, but false is not the same as true. So therefore, the evaluation is true. So while this is true, we're going to keep doing the code that's within the curly braces. And it looks like there are 3 lines of code, of which one of which is a part of an if statement. So take class, whatever that means. And then we have, if you passed your last class, then graduated is true. Okay, so a very important part of this is this. Since the Boolean up at the top is checking graduated, eventually something in the loop must change the Boolean. And the reason this is true is because otherwise the Boolean would never change, and therefore the loop would never stop. As long as this Boolean at the top is true, the loop will keep going. 1 time, 5 times, 10 times, 100 times, 1,000 times, 1,000,000 times, 50 million times, 1 billion times. Until your computer is turned off, this while loop will keep going until that Boolean comes out to false. So hopefully something in the loop is actually affecting the Boolean, because if nothing in the loop is affecting the Boolean, then the Boolean is always going to be always going to be true. So somewhere in here, we are going to specify that graduated is now true, and that's done with this if statement. So we keep going until the if statement flips it, and then as soon as the if statement flips it, at that point, we stop going through the loop. All right. So this is basically how a Boolean expression is used in a while statement. The while statement will always have the word while, it will always have those parentheses, and it will always have the curly braces with the code in it. And somewhere in that code, there should be something that will eventually change the Boolean condition that we're checking. Otherwise, it's never going to stop. All right, so let's look at another example. So here's some actual Java code, class main, public static void main. And then we start off and we are going to declare a character called letter, and we're going to set it equal to A. And then we have a while loop that says while A is less than Z, which A is less than Z, it understands the order of the letters. So A is less than Z. So while A is less than Z, it's going to print out the letter, which is the variable that we're using in the loop, followed by a space. That's just what that plus space, double quote, space, double quote is. And then letter plus plus. And that might be a little confusing, so let's talk about that. Just like numbers, because the letters are numeric, it knows that A comes before B, which comes before C, and so you can just say letter plus plus if you have a character. So the character A plus plus is B, and the character B plus plus is C, and so on and so forth. So overall, what's going to happen here is we set letter to A. So if we keep track of letter over here, it's initially going to be A according to that statement. And then it checks the while condition. Is A less than Z? And that is true. So yes, as long as it's true, we're going to go in here and we're going to print out letter, which is going to print out an A followed by a space. I'm just going to draw that for a space. And then it says letter plus plus. Well, when we do letter plus plus, it's going to change the value of A to a B. And then we reach the bottom of the loop. And when we reach the bottom of the loop, it's always going to come back around up to the top of the loop. And then we're going to go do the test again. So now it's checking, is B less than Z? And B is less than Z, so that is still true. So again, we're going to move into the loop. That tells us to print out the letter, so we're going to get a B followed by a space. And then it's going to do letter plus plus. So B is now equal to, letter is now equal to C. Again, we reach the bottom of the loop, we go back up to the top, we check the condition. C is still less than Z, so that's still true. So we print out C and a space, and then we increment letter again. Now it's D. And so I think what you can see is the final output of this is what's written down there. Let's get to the very end of this. So let's talk about the circumstance where letter has reached X. And let's just continue tracing. So we go back up to the top of the while loop and it says X less than Z, and that is true. So prints out the X and prints out the space. And then it does letter plus plus. Well, at this point, that becomes Y. And we go back up to the top of the loop. Y less than Z is still true. So it prints out the letter. So you get your Y and a space. And then it does letter plus plus. And at this point, letter is now equal to Z. All right. So now, something that to be very clear about is, if there were any more lines of code in here, below letter plus plus, they would continue to execute, even though we are now in violation of the term for the loop, because Z is not less than Z, right? So we know that when we get back up and we test this condition, it's no longer going to be true. But that doesn't immediately stop the loop. If there were any more code underneath letter plus plus, we would continue doing that code even while letter is equal to Z. The only time that we check the condition is when we reach that closing curly brace and get sent back up to the top of the loop, which happens to be now. So letter just became Z, and so we get back up to the top of the loop and it's checking Z less than Z, and that is not true. Z is not less than Z. So as a result, once this is false, the loop is going to stop. And very specifically what's going to happen is we're going to move on to the line of code underneath the closing curly brace. And this is why we have these closing curly braces in there, because this is related to this. They are the beginning and the end of the while loop. And so the while loop will do everything in between those 2 points until the Boolean is false. And once the Boolean is false, it will move on to the line underneath the closing curly brace, whatever that may be. All right, so that's how a while loop works. We're going to do a couple more examples of that just so that we can see. So the first thing to notice here is that we did a lot with a very small amount of code. We outputted 25 things, A through Z, or I guess 24 because we didn't print out Z. But there was really only 9 lines of code in there. If we go back and look at this, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9. So with 9 lines of code, I was able to do 25 things or 24 things. And that's the computer's strong point. Doing something over and over again is something that computers are very, very good at. You give them a task and you let them do it. This is why robotics, people use robotics, right, in factories. I need you to pick up this door and I need you to put it on the car. And then I need you to pick up the next door and put it on the next car, and pick up the next door and put it on the next car. A computer can do something like that very, very efficiently, and it will continue doing it without ever getting bored. We as humans are not so great at that. Once you get used to doing something, after a while you get bored of it and you'll start making mistakes and you'll slow down and you'll start doing the wrong thing, especially for more complex tasks. So this is honestly one of the main reasons why computers are so successful, is their ability to repeat things over and over again for us. And you can do a lot with loops. You can write very complex code that does very complex things that's in a loop, and therefore the computer will do it over and over again. So this is one of the strongest points of a computer. All right, so let's do another loop here. And so what we're going to do in this case is we're going to look at another set of Java code. So we have the usual importing of scanner, and then we have the usual class main and public static void main. So nothing wild there. We create a scanner object, which we've done a million times. All right, so the first line of real code here is I set a variable called secret equals to 15. And you're not supposed to know 15. All right, so pretend like you don't know that. But there is a variable called secret and it has 15 in it. And then I'm going to print out and I'm going to ask the user to enter in a number. So basically I'm telling them, what is the number I'm thinking of? That's what the computer's going to write on the screen. And then we're going to wait for the user to type in their guess. And whatever guess they give me, I'm going to store that in user guess. Okay, so then I have a while loop, and I say while the user's guess is not equal to the secret, i.e. they haven't guessed the secret, then we're going to keep asking them over and over again for more guesses. And then eventually, when we get out of this loop, we're going to print out U1. Okay, so if we trace this code and we actually run it, what you're going to see is this. This is the output. So the very first line is, what is the number that I'm thinking of? And that comes from right here. And then the user types in the number 10, and that's coming from this statement right here. And since 10 is not equal to 15, which is the secret, this Boolean expression is true. So 10 is not equal to 15 is true. So therefore, the loop is going to keep going for now. So then, guess again comes from this line, and the user enters in their guess into user guess on this line. So this time they guess 20. So now when we reach the bottom of the loop, when we go back up to the top, it checks, is 20 not equal to the secret? And 20 is still not equal to the secret. So because that's true, we're going to go again. So this time we're going to do a guess again, and then we're going to read in another number from the user. And it turns out this time the user gave us the right answer. So when we go back up and we check, 15 not equal to 15 is false. And since it's false, it's going to move on to the next line of code down below the loop, which is going to be that system.out.println line of U1. So the loop is going to continue going until it gets the correct answer. And in this case, the user managed to get the correct answer in what looks like 3 tries. But it's actually possible that they could run it forever and ever and ever and maybe not ever get the correct answer. So this will keep running. And this is just another example where it says, what number am I thinking? 10, no. 20, no. 30, no. 40, no. 50, no. 1, 2, 3, 4, 11, 12, 13, 14, 15. Yay, you won. But the computer could have done this 1,000 times if the user kept guessing the wrong answers. And that's what I want you to realize, is that this keeps going until the user does the correct thing or picks the right thing. Okay, so a couple of things that all while loops have. They will always have the word while. They will always have those parentheses with a Boolean expression inside of them, and they will always have a set of curly braces with some code inside of them that is the code that you actually want to repeat. All right, so now we're going to do another example. So how many times will this print the word hello? All right, so let's take a look at this code. And what we're going to do is we're going to trace this code because it's interesting to look at how a loop is running, and we want to be able to do it the same way so that we're checking what's going on. So we start off and we have x is equal to 0. So I'm just going to keep track of my x over here. I'm going to say x is equal to 0. All right, so let's check this while condition. 0 greater than 0. Is that true or false? Well, it turns out that that's false. Okay, so what happens when this is false is that a while loop will move to the next line of code after the while loop. And this is a bit confusing. It seems like we never did the loop. And you're right, we never did the loop here. Why? Because the while condition was false straight away. X greater than 0 is just false, because if x is 0 and 0 greater than 0 is false. So my point of this example is that while loops, much like if statements, they don't have to run. They only run if the evaluation of the Boolean turns out to be true. And in this particular case, it didn't. So therefore, this will print out the word hello, never. Now, if you wanted it to print out the word hello, you would set this to 1 or 2 or 3, and then it would actually work, although it will have a whole new problem, which we'll talk about in a moment. Okay, so the point of this slide is to tell you, don't just look at a while loop and assume that it's going to do something in particular. You need to actually read through the code and try to follow the loop and see what it will actually do, because in some cases the while loop may never happen. In some cases it may happen 3 times, in some cases it may happen 1,000 times, and there's no way to know other than to follow actually trace through the code and see what's going on. And so that's what we're going to do. I'm going to show you how to trace a loop in this example. So here we have x is equal to 0. So we're going to have our x and we're going to keep track of it over here. And then we also have a test where 0 is less than 5. And that one's going to be true. So we are going to go in and do our loop. All right, so I'm going to do this on a different set of the slides so that you have this to go with you down the road. So in this layout, what I'm doing is up here, I'm keeping track of any output on the screen. And down here, I'm going to keep track of any of the variables that we have inside of our code. And so that's what's going on over here. And this is a pretty typical way to trace a loop. And you should get used to this idea of how to trace it. You keep track of the variables and you just update it going line by line. This blue line up in the top corner over here, this arrow, this is how we're going to see which line of code that we're currently evaluating. So at the moment, we're looking at class main, and that doesn't really do much of anything. So then we're going to move on and we're going to begin our main method. And this is how code execution works. You start at the main method. Okay, so the very first thing that happened here was that we got a variable x and we set it equal to 0. So we're keeping track over in our variables that we have an x and it is now equal to 0. All right, so next up what we have is x while x is less than 5. Okay, so 0, which is the current value of x, less than 5 is true. And so therefore, we are going to go into our loop. So 0 is less than 5. So we move on to the next thing, which prints out the word hello. Next up, we do an x++, and that changes our variable from 0 to 1. Notice down in the bottom right-hand corner there, it went from 0 to 1. All right, and now we reach the end of the while loop. And every time we reach the end of the while loop, we are going to go back to the top of the loop, and then we're going to evaluate the while condition. So in this case, the while condition is while x is less than 5. Currently, x is 1. 1 is less than 5. That's true. So we're going to continue into the loop. All right, we print out hello, and we're going to change the value of x again. So x is now equal to 2. We reach the end of the loop, which is going to send us back up to the top of the loop again. And when we reach the top of the loop, we're going to reevaluate the value of x, or the Boolean condition. So x, which is 2, less than 5 is still true. So we're going to go into the loop, we're going to print out hello, and we're going to add 1 to the value of x. X is now 3. We reach the bottom of the loop, which sends us back to the top. When we get to the top, we have to reevaluate the Boolean. 3 less than 5, that is true. So we're going to go back into the loop. We're going to print hello. We're going to add 1 to the x. X is now 4. We reach the bottom of the loop, which sends us back up to the top. 4 less than 5, still true. Print out hello again. Add 1 to the x. X is now equal to 5. Okay, and again, what I was saying earlier is this does not immediately stop the loop. It's just that we know when we get back and we test the while loop, that's when we're going to see that it doesn't work. So x is now 5. We reach the end of the loop, which sends us back up to the top, and now it evaluates the condition. 5 less than 5 is false, so the loop stops. So watch where the arrow goes. It doesn't go back into the loop. It goes down to the line after the loop. All right, and then at that point, if there's any more code down there, we do that. But in this case, that's the end of the main method and the end of the class, so we're actually done. And the final output of this was we got 5 hellos. All right, so if you look at this loop, x started at 0, and through the loop, x was initially 0, then it was 1, then it was 2, then it was 3, then it was 4, and then it was 5. When we got to 5, the loop stopped, but it printed hello because of each of these lines, and you'll notice it did it 1, 2, 3, 4, 5 times, which is why we get 5 hellos up here. All right, so that's how you trace a loop. You just keep track of the variable off to the right, you keep track of what the value in the variable is, and then you just walk through the code and see what the code is telling you to do. Don't make assumptions by looking at it and trying to say, oh, it's going to do something 15 times. Just follow the code. Do exactly what the code is telling you to do. All right? So that's the basics of how you're going to go about doing a while loop. Basically, you're going to have a condition that you're going to check, and as long as that condition is true, the loop is going to keep running over and over again. At any point, if the condition becomes false, you're going to stop running that loop. And so you should get used to the idea of writing this. I would suggest take this code and put it into Replit, and then see if you can change it so that you get hello 10 times, or you get hello 3 times, or you get hello 15 times. Or change the output from hello to something else. And notice what happens as you add more lines inside the loop in this area right here, so that you can actually have the loop do more than just this. You could have it print hello and goodbye and all kinds of other things in there as well. It would also be interesting to put a couple of extra lines of code down here after the while loop is over, just so you can see how they execute. And there was an example of that when we did the guessing game a while ago in the same slide deck. I'll try and scroll back to it, but it's a long way back. But that guessing game, we used code that was after the while loop. And so here it is here. And again, this one will be worthwhile typing into a Replit or in IntelliJ and giving it a run and seeing what goes on and play it and see if you can make it actually do stuff. The downside of this guessing game, of course, is that you're always guessing 15, but you've seen code how you can have the computer pick a random number and you could modify it so that it actually is challenging and you don't know what the answer is up front. In this case, you know the answer is always going to be 15. So I'd highly recommend that you take some time and you do some practice with the while loop and just get a feel for how it works. And then in the next lecture, we're going to talk about some more different stuff that you can do with loops. So I will see you then.